Pre-calcers, you're back again with P5 with factoring polynomials. Did you pay attention in Algebra 2? Did you see all of these types of trinomials that you were trying to rewrite in terms like this? Do you remember that? What it was originally looking like? Something like ax squared plus bx plus c when those a, b, and c were equal to numbers. Do you remember that? If you don't, you're watching the right video. You have someone who's pretty confident about all of this. I'm actually really confident and competent with all of this. But before we get into that, a few of the objectives. What are we doing? We're going to be factoring out the greatest common factor of a polynomial, more so with the examples you'll be working on, not so much here, because that stuff's kind of easy. Factoring by grouping, which can be a little bit more complex with factoring. We don't see a difference of squares here, but that's a pretty easy one to spot. I don't think any of these are perfect square trinomials, but it's a lot of factoring, so that's the main thing to take away here. So what does factoring do? Factoring allows us to take complex looking, intimidating looking trinomials like this. Like let's say this is 10x squared plus 3x plus 9. And it gives some hope that you can rewrite it in the factored form, where if you were to multiply this out, it gets you back to the trinomial, which would be 10x squared plus 3x plus 9. I think this is actually prime, but who's judging me? So let's kick into one that I think is pretty easy. So we have x squared minus 3x minus 14. This is pushing us to factor this completely. Sometimes we have to second guess ourselves and we might not be done just yet. So how I approach this, I use what they call the Dimond Method. And what this Dimond Method does is just keeps your information organized so that you just don't jump to conclusions and make an error. This keeps your work pretty organized. So how does this work? Draw an X like so. Some people debate this doesn't really look like a diamond, but I call it Dimond Method. So shine bright like one. This will allow us to take the information that's in here. So we take the C constant, the B coefficient for X, and A we don't really touch on because the A coefficient in this case is just 1. So this only works if your A coefficient's 1. We'll see the other version in a bit, but the main thing to take away is that this Dimond Method is simple if the A coefficient is 1. So we put our C constant in the bottom, negative 14, negative 13 up top. We will refer to this also as our product because we're aiming for numbers that multiply together to get us negative 14, but add up together when combined like a sum to get us negative 13. So let's think. We know that our product's negative, so one of our factors, we'll put factors here and here, one of the factors has to be negative. So right off the bat, I know this is going to have one negative factor. And so let's think, factors of 14. Well, there's 1 and 14, there's 2 and 7. Can you think of any other factors of 14? Good, you shouldn't, because there's no other ones. So let's think, out of these two options, the 1 and 14 or the 2 and 7, which of these seems closer to 13 if you were to combine them? And keep in mind, one of these can be negative. Sometimes you can go trial and error with this, but if you had negative 14 and you added 1, let's check. Does negative 14 plus 1 get you negative 13? Does it? What do you think? It does. So we can double check to this. We can make sure that negative 14 plus 1 gets us negative 13. So that part's true. Negative 14 times 1 gets us negative 14, so that's true. So we're allowed to just run ahead and say, well, the answer, the first two terms when multiplied give us x squared, so our variable is definitely x and x. The two factors we want are negative 14 and 1, so we throw those in, and this is considered the most factored form. But wait, pump the brakes. Is there a way we can check this that we've already seen? We could use box method for sure. If you did all of that, your work would look something like this. And again, this is just to check your work. Because if you're going to put in all this work, why not be confident with it? If you filled in everything here, x squared minus 14x plus x minus 14, you would see that everything combines back to the original trinomial, which is what you want. So we're good here. So our final answer is in parentheses x minus 14, x plus 1. We're good there. With the next bit, this is a little bit more complex, but let's look at both of these. What's different? They both have x squared, they both have x, but what about some other features? What's different? Look for patterns. It's already given to you really, but you should notice that the a coefficient's no longer 1. So the work here is a little bit more complex. So you kind of have to hold back on what we did here and be open to this new approach. Not new approach, but this other approach that we need to use if we want to be successful here. So we are still going to be labeling what A is, what B is, what C is. We're still setting up Dimond. But now instead of just C in the bottom, this is now the product of A times C. So what's 3 times negative 5? Should be saying negative 15. And B still is the same, that goes up here. So still negative 2, same as it ever was. And so now we're thinking of factors of negative 15. So this is still our product that add up to negative 2, our sum. So there's 1 and 15. There's also 3 and 5, no other ones. What can we conclude about one of these factors since this is a negative 15? Should be saying we can conclude one of them has to be negative. And that's true. All right, well, what can we do with this? 1 and 15, that's not really going to get close to negative 2, but 3 and 5, that has definitely a shot. So let's say if one of them's negative 5, the other is positive 3, our factors are here, that matches out, cool. All right, so what does this mean? But we can't just run ahead and say that it's going to be x plus 3x minus 5. Let me demonstrate. You cannot just jump ahead here and say this. And the reason that is because we have an a coefficient that's not 1. So this is a little bit more complex. So don't run into this. Do not do it. So the approach we take is by using factoring by grouping. So if we factor by grouping, it's as if we start out by rewriting the first term, which was 3x squared, and then we throw in our factors of plus 3x, minus 5x, minus 5. All right, well, this still doesn't look as if it's in a factored form with parentheses. So what do? We focus on the first two terms. So the first two terms are as follows: 3x squared plus 3x. Is there anything we can factor out of these two terms? A common number, common variable? You should be saying 3x. So 3x, let's take that out. What times 3x gets you 3x squared? Well, that's x. 3x times 1 gets you 3x. And so we really just rewrote the first two terms. And this x plus 1 is actually going to be really important because we did this correctly. And if we did this factoring of the first two terms correctly, we're going to have another x plus 1 over here. And this is kind of a quick way to go through the problem, just jumping ahead and rewriting it here. But now, if we focus on the last two terms and factor out there, what would we have to factor out from these two terms so that x plus 1 is a factor? Well, you could write in negative 5. If you're not convinced, distribute it back in. And so our final answer, where we are approaching, uses these two greatest common factors. So let's throw in parentheses, 3x minus 5. And then we just use one version of the x plus 1. So this is our final answer. And we're done. If you are interested, you can try this next problem. This is a little bit more tricky. If you want to pause it and try it on your own, this will use factoring by grouping because there are 4 terms similar to what we had here. So this kind of gave you a heads up as to how this one works. So if you want to pause it, try it on your own, go for it. It's kind of complex. But I'll actually help you out here. So if we factor by grouping, we can move around some of these terms just a little bit. Let's see. We could move out, well, what's common with this and this? You can move out x. You would need x squared here. Need that. You would need y squared there. What else can we do? 32 and 50 are divisible by 2. You could say that this is 2x factored out, and then 16y squared. You can then deduct 25. You can then take that idea further, so you know that you'll need this to be 16y squared minus 25. So here you would have to factor out, what, negative 3? You can take this further so that it's going to be, when grouping is pushed, you have 2x minus 3, 16y squared minus 25. Again, this is a tricky one, so if you're passing on this, that's okay. But here you see a difference of squares, which is something you probably heard of in Algebra 2, which I abbreviate to DOS, which allows us to rewrite this because 16 and 25 are perfect squares. Square root of 16 is 4, y is here and here. Square root of 25 is 5. Make one positive, one negative. And this would actually be the most factored way to rewrite this polynomial. So that last one's tough, but the main thing to understand here would be these two problems. But this is definitely something that you should be open to trying. It's possible. Thanks for watching. If you have any questions, bring them to class. Take care.